This is PH 1501 Unit 1 Vector Analysis by Dr. M.R. Gadhvi. The prescribed textbook in the syllabus, that is Introduction to the Electrodynamics by David J. Griffith. Publisher is the Pearson. Well, the chapter 1 unit 1.1 is kind of what you had already studied in 11th and 12th grade standard. So it is in a way it's easy to understand the unit 1.1, that is a vector operation. As you are aware, in the physical quantities, you having two kind of varieties. One is a vector and another is the scalar. The vector quantities, that means it should having two parameters. One is a direction and another is a magnitude. Few examples very well known: velocity, acceleration, force, momentum, etc. Whereas the scalar quantity, that is such having a doesn't have the direction, rather you do not require to show them their directions, or rather you can say that it remain constant, it remain invariant with the directions. Like you said the temperature of a room, तो आपको पता है कि रूम का टेम्परेचर ऑलमोस्ट सिमिलर रहेगा, राइट. वेल आप बात कर लो कोई एक मास की, मास ऑफ अ बुक लेट अस से, और अवर टेक्स्ट बुक इलेक्ट्रोडायनेमिक्स इटसेल्फ, राइट. तो वो बुक का मास है, वो कहीं से भी आप मेजर करो, खड़ी रख के करो या उसको सुला के करो या उसको टेढ़ी करके करो, मास रिमेन इनवेरिएंट. दैट मीन्स द डायरेक्शन doesn't change it. But there are some quantities like acceleration and velocity and force, तो it is a direction dependent. जब आप फोर्स दे रहे हो और आप साइड चेंज कर लो तो आपको it would be in a different direction. So you can feel that it is a direction dependent quantity. Anyway, so in this book, this everything you are aware, so I am not underlining too much. Please read the book, you will enjoy it. It's very nicely written book. So in this book all the vectors are written in the bold face. माने जो भी bold character आपको दिख रहा है, that is your vector. Okay, and the magnitude उसका अगर दिखाना है, so as I said in vector that you having a two thing, directions and the magnitude. So direction part, that is a vector, is written like this, bold A, and the magnitude is written like the A in a mode, or sometime it is written non-bold phase, so that is a A. So that is there. So like let us take a very simple example. Author is from the US, so he is using the word like Washington DC and the Baltimore and so on. So if you are moving, let us say from Washington to Baltimore in the direction by 4 miles, and from Baltimore to the certain another directions by 3 miles. So basically you are walking some around by 4 plus 3, 7 distance. But actually the displacement is, we are starting with the head of a one. So this is a arrow, that is a direction. So this is referred as a tail and this is referred as a head. So our beginning point is always with the tail and it is joining to the head. Then another arrow or another direction, its tail is joining to the head. So head to tail and then tail to head. So now you have to again go with the head to tail. So this is your overall displacement. So 5 miles is your overall displacement. This is your travel distance. I hope you can understand. You are changing your directions. This is your magnitude. Then again you are changing your direction, your magnitude, but the net summation, net effect, the resultant what you have seen, that would be the 5 miles. So this is called the addition of the two vectors. We will definitely see in the detail as well. Same way, here it's nicely written, neglecting of course the curvature of the earth. So when you are talking about this this movement on this one, ideally being a student of a physics, you should know that the earth is a spherical globe. It's a sphere, or it's like a globe. So where the curvature are, we are not taking care of it, because ultimately it's a mathematics and one should think of it. But anyway, so author is very sensitive to write this one, so he is saying that we are neglecting those parts. Anyway, suppose a vector is going in a top to upward direction with the it is bold, that means it is the character vector. So suppose I am drawing out and same size of a vector, same size of a length of a arrow with the opposite direction, then I can mention it with the negative a, or the another side moving vector. So here the very first property we would like to learn, that is the addition of two vectors. So let us say this is vector A, so tail, it start from tail to head, and the B tail is start from the head of A to the B head. Then we are joining the tail of A to head of the B, so that is A plus B. The same diagram I can represent it in the another way of a representation. So the B I am writing over here, so it's a just, I think you are knowing the parallelogram formula or parallelogram representation. So this is the upper arm of the parallelogram I am showing at the bottom, and this is I am showing from left edge to the right edge. So B plus A, and the net summation is again it's a BA. So the in a bracket, if you look at minutely, it's a plus B, so vector A added to the vector B, or you can write it out, the vector B is added to the vector A, and this is property is called the addition property of two vectors, which is referred as a commutative. That means you can commute from either end. You can either commute from A to B, or you can commute from B to A. The answer is remain unaltered, it is remain same. So this rule is generalized the obvious procedure of a combining of a two displacements. ठीक है, इसका मतलब आप दो डिस्प्लेसमेंट को कंबाइन कर सकते हो, a प्लस बी, और या तो आप b प्लस ए बोलो, बात एक ही बन रही है. ठीक है, इसके बारे में और एक लिखा है कि 3 miles is followed by the 4 miles. North gets you to the same place if you are moves 4 mile in a north and followed by the 3 mile. माने पहले आप यूं 3 माइल चलो और फिर यूं 4 माइल चलो, या तो फिर यूं 4 माइल चलो और फिर यूं 3 माइल चलो, आप डेस्टिनेशन तो सेम पॉइंट पे ही पहुंचोगे. सो द इट इज़ अ कम्यूटेटिव, ए प्लस बी करो या तो बी प्लस ए करो, योर डेस्टिनेशन विल नॉट रिमेन चेंज. एंड एडिशन, दूसरी प्रॉपर्टी जो एडिशन ऑफ वेक्टर की है, दैट इज़ अ एडिशन इज ऑल्सो एसोसिएटिव. एंड दिस एसोसिएटिव दैट मीन्स अगर आप एक ग्रुप बनाओ, ए प्लस वेक्टर ए इज सम्ड अप विद द वेक्टर बी एंड इट सम अप विद द वेक्टर सी. तो इसमें मैंने एक ग्रुप ये बनाया कि ए प्लस बी का एक ग्रुप है, एंड द समेशन ऑफ ए प्लस बी आई एम एडेड टू द वेक्टर सी. ठीक है, सो नाउ हियर आई कैन से दैट द vector A is added to the summation of the B plus C. So you are making association with the different. यहाँ पे A plus B का association है, and that is added to the C. Here A is added to the association of the B plus C. So it is also remain unaltered, and that is called the property that is referred in the case of a part of a addition. So addition of a two vectors is also referred as a, it is having a property that is it is associative. Okay, and the last is in the case of its addition is nothing but the subtractor is also part of addition. So because here the, let us say this arrow I am showing in a other direction, so this is the arrow, if I will alter it, okay, this B I am putting here in the opposite direction. So this is A and this is opposite direction in a B. So the net summation is referred as a A plus B, but B with the negative sign. So instead of a positive I will write it out the. So this is basically a subtraction of the two vectors. So that is called the shown in the figure number. Thank you so much for paying attention. Stay home, stay safe, good luck.